talking about identifying, generating geometric sequences, writing explicit formulas, recursive formulas, everything we kind of talked about in general in lesson 11.1, we're going to talk about specifically today. A geometric sequence has a common ratio. So we're not adding a number each time to get to the next number. We are multiplying each time to get to the next number. We might be multiplying by a fraction. We might be multiplying by 1/2 or 1/3 or 2/7 or whatever. Might be a negative. So we might have a positive and a negative and a positive and a negative and a positive and a negative. Okay? So it's very possible that our sequence will alternate signs because our common ratio is negative. Okay? So a geometric sequence has a common ratio. Okay? The way to find that ratio is to take a term, I'm just going to say n, and divide it by the previous term, n minus 1. Okay? The way to find the ratio is to take a term and divide it by the previous term. That'll give you the common ratio. That'll tell you what did I do each time to get to the next number. All right? Any questions on that? So for an example, if I have 8, 16, 32, 64, okay? Most of you look at that and say, well, what's our common ratio? I'm multiplying by 2. But if I apply this rule to it, I would say, well, let's take, say, the second term, which is 16, and divide it by the previous term. That's what that symbolism means. The previous term was 8. And 16 divided by 8 is 2. So my common ratio is 2.
Why is it, say you said 8, but what is the thing for n minus 1? Is that just going to say you're plugging in your first term?
No. It's saying the previous term. So if I didn't start with 16, let's say I started with 64.
So 32 would be
Then if I chose 64, then the previous term would be 32. 64 divided 32 is still 2. Okay? Now if they ask you if the sequence is geometric, then this is how you would test it. You would have to divide a number by its previous term and get a common ratio, and then check it with another one. And to be absolutely certain, you'd have to check it with every term they give you. And if I checked it here, well, what's 32 divide 16? 2. And we already said 16 divide 8 is 2. And so in every one of these, we had a common ratio of 2. So it's geometric. I'm multiplying by 2 each time. Okay? Any questions on how to find the ratio, how to test whether it's geometric? Any questions on what is a geometric sequence? Okay. Then let's talk about a recursive formula. And then we'll talk about explicit, but leave yourself a little room here. All right, so recursive, in arithmetic, recursive meant what? We have the first term, and then they tell us what to add to it to get the next term each time, right? So recursive in geometric would be very similar. We have the first term, whatever it is, we'll call it A, and then we're going to take the previous term, and we're going to times by it the common ratio. And so my nth term is going to be my previous term, my n minus 1 term, times r. So that's what geometric recursive looks like.
What's our R?
What's that?
What's our R then?
R is a common ratio. So in the example we did on the previous screen, it was 2. Okay? If I had this sequence, let's say 27, 9, 3, 1,
It'd be times.
okay?
You'd be multiplying by 3, or multiplying by 1/3.
Yeah, I'm actually dividing by 3, right? So my common ratio would be
1/3.
1/3. And so what's my first term?
My first term is 27.
27. So my recursive formula would be a sub 1 equals 27. And then a sub n is going to equal,
The
27 was the previous term.
how do I write previous term?
A of n minus 1.
A of n minus 1. And then what?
And then you multiply it by 1/3.
Okay.
1/3 ratio.
And multiply by 1/3. Okay? So we just wrote the recursive formula for that sequence.
And you can also plug it at 27 for the A of n. Since you know that it's the first term.
Yeah, if I want the second term, but if I want the formula for any term number,
Yeah.
I need to leave it this way. Okay? Now, if someone says find the next 3 terms, then I'd say, okay, I have 4 already, so the 5th term would be the 4th term times 1/3, right?
Yeah.
Well, we know the 4th term is 1.
Yeah. It is, for some reason, it feels incomplete with having 2 variables.
I
out
understand.
there.
Yep, I get it. It's very well said. He's saying this feels really incomplete to leave my formula this way with 2 unknowns in it. And I totally get it. But that's the way it's
But,
done.
Yeah, that's because you will have the first term.
Right.
in,
Right. Okay? Recursive is only handy if they only want the first few terms. If they want a term way down the road, it's not at all very, very helpful. Okay? Not at all. So explicit. What's nice about an explicit formula?
You can find it define, like, later terms.
That's right, I can find any term I want, can't I? You tell me which term you want, I can find it with this formula. And the motto is a sub 1 times r to the n minus 1. Okay? Now this no longer means previous term. This is not a subscript,
Yeah,
it's
it's a
an
number.
exponent, it's a power. Okay?
Number minus 1.
N stands for the number of the term you want.
Is that still going to be the common ratio?
Yeah, R is still the common ratio. Let's identify these to make sure we get it. This is the first term. This is the common ratio. And this is the number of the term we want. Sorry, I didn't write that very neatly. Okay, and this, the a sub n would be the value of the, I'll say, desired term. Okay, the value of the desired term. So just to make sure we don't look at this later, like say on a quiz after Christmas break and say, oh, what did that mean again? And then you'll have it there. If you put that in your notes, you'll have what those letters represent. So if I want to write the explicit formula for this sequence right here,
A1
so we would say a sub n equals,
A1.
which is,
That's
First term of the.
of this sequence,
So
27.
27. times,
third, n minus 1.
okay, in fact, it might be even better to use parentheses. And to what power?
N minus 1.
N minus 1.
How would you find that, or would you not find it? You just leave it at that.
That is my formula. Now, if Taylor says, well, what would the 100th term be? Then I would plug 100 in for n. 100 minus 1 is 99. And I'd say, what is 27 times 1/3 to the 99th power?
And wouldn't it be proper to put a subscript in 100 if you wanted to find the 100th term?
Yeah. Yeah, so he's saying we should write it this way. I agree completely. So a sub 100 means the value of the 100 term is 27 times 1/3 to the 99th. Do I need to substitute and show 100 minus 1, or are we okay with, I got 99 from 100 minus 1? Probably not going to be a very nice answer. Okay? Probably not going to be a very nice answer. In fact, I'm not even sure you'll get an answer. Some answers are even too big for your calculators. So go ahead for kicks and giggles, see if you can get an answer, or if it just doesn't give you anything nice.
Yeah, it doesn't give you a scientific.
Okay, I live with that. What is it?
1.57166343.
Slow down. 5.7?
1.57.
Oh.
I got the actual answer.
1.
Times 10 to the what?
Negative 46. You don't need to carry on that long, yes.
Negative 46.
Oh. Thank you.
I got a different answer because I just ready to copy. I put it in fraction form and I got. Oh, it's in fraction form.
Is the homework going to be harder or
Okay, any questions on that?
So I got 1 divided by this huge number. I got
Yeah.
1 divided by this.
All right. You should have 1 divided by 1.57 times 10 to the 46. Okay. All right. One last thing. Yesterday we did arithmetic mean. Today we're doing geometric mean. Yesterday, if we had 3 terms here, we're looking for the arithmetic mean. What did we do to find it yesterday? I added the first and the third, and I divided it by 2, and that gave me the middle term, right? Well, today, if I have these first and third terms, and I want that middle term, the geometric mean is going to be equal to the square root of the product of 0.1 times 0.3. So it's the product of the 2 numbers, and then the square root of it will give me the geometric mean. Okay? So the geometric mean is I find the product. So if I want the geometric mean of 2 and 8, then I'm going to say
Would it be
the square root of 2 times 8,
16?
which is the square root of 16, which is 4.
Four.
You want it in simplest radical?
Say that again?
You want it in simplest radical form?
Yeah, if they ask, unless they say a decimal. Unless they say a decimal, we normally leave it in simplest radical form.
So the equation would be P2 equals the square root of the quantity of P1.
Yeah, for geometric mean.
Also not
Yeah.
not for any middle term, just for.
Yeah,
That would be.
it would be that we're kind of saying the same thing.
Yeah.
Okay? Any questions on that? All right. Let me pause while we stick with 452 by 4.